any cone, let us do one more activity. Let us first take a cylinder whose height is h and the radius is r. So the volume of this cylinder becomes V is equal to pi r square h, which we have just now derived. Let us take a cone having the same height and having the same radius. That means here also the radius is r as usual. Here the radius is r. Let us make a cone in this way, in which this becomes the height h. So we have cone on the right side, cylinder on the left side, having the same radius and same height. Now let us fulfill this cone with water up to the brim, and then let us pour this water over here. So when you first pour water to this portion, it will take 1/3 of the cylinder. Practically you can do at your home. Again when you put one more, then it will raise up till here. Finally when the third time you fill this cone till your brim and you pour, the cylinder gets fulfilled. That means what we have learned from this activity? We have learned that 3 times the volume of cone, this volume of the cone having the same radius as cylinder and the same height as a cylinder, 3 times the volume of cone is equal to volume of cylinder. That means from this we can find it out. That is 3 into volume of cone is equal to volume of cylinder. We know that pi r square h, pi r square h. Therefore volume of cone is equal to, bring this 3 this side, it gets divided, that is 1/3 pi r square h. So in this way we can derive the formula of volume of cone. Let us go with one more geometrical figure, that is sphere. Sphere is in the form of football, you can say, or volleyball, or you can go with a tennis ball, or you can go with cricket ball. So it is also a 3-dimensional sphere is a 3-dimensional figure. In this we can find out, this is a sphere having radius r. This is a 3-dimensional figure. So the area of sphere, that is curved surface area of sphere, is equal to 4 pi r square. Now if we do a semi-section, if we cut over here, then it becomes a hemisphere. Now see this. If now the total surface area of hemisphere, so this is a hemisphere, this surface area is half of the area of the sphere, that is 2 pi r square. Again this is the circle, we are getting downward, below the downward, just like water. If you cut the watermelon, you can see this type of red spots and all. So this becomes another circle. So this circle area is pi r square. Therefore total surface area of hemisphere is equals to 2 pi r square plus pi r square. It becomes 2 pi r square plus pi r square is 3 pi r square. So we got the total surface area of the hemisphere, we got the total surface area of a sphere. Okay, now we'll try to find out the volume of a sphere. So to find out the volume of a sphere, my dear, let us go with one more activity. sphere of radius r, let us take a cone of radius r, and if you draw a dotted line through the center, this becomes the height of the sphere, that means r plus r, 2r. Similarly, we take a cone of height h, which is equals to this 2r, and radius r. Clear? Now let us take again water in this cone and fill it up. After filling up this, let us pour that water inside this sphere. So likewise, if you pour 4 times the volume of cone, then only the sphere is going to be filled up. That means the volume of sphere, is equal to, having radius r, is equal to, how many times you have to fill up this? 4 times the volume of the cone inside this sphere. That means volume of sphere whose radius is r is equals to 4 times the volume of the cone. Already we have derived what is the volume of the cone. The volume of the cone is 1 by 3 pi r square h. Hence the volume of the sphere is 4 into 1 by 3 pi r square h, or you can write 4 by 3 pi r square h. In this way we can derive any mathematical formula of geometrical shapes. Thank you. If you have any kind of doubt regarding the derivation, or if you have any types of doubt in solving problems, just comment in the comment box, and as soon as possible I'll try to explain you everything in my YouTube channel. Thank you.